So this is the third section in the expressions topic in Algebra Tutor in this little walkthrough tutorial. So we're going to be looking at nested terms. So terms inside of other terms. So if multiplication and division glue things together into the same term, and plus and minus signs at the beginning of new terms, they start new terms. What happens if we want to take a sum, so a sum is a list of terms, and multiply that whole sum as if it was a factor within a product? So we want to multiply or divide the whole sum by something. This can lead to having nested terms. So we're going to be using something that begins with B and ends in rackets. And then we'll also look at some particular definitions of certain types of terms. So some vocabulary to do with some particular types of terms and expressions. Remember, when you know, even in mathematics, even when you come across words that you don't recognise or use, you can use a dictionary. That can be a great way to try and find out what things mean. Okay, let's start this then. Right, so let's have a look at this example to think about what we're doing here. So I've got some pots and pens down here. So here's a pot where I've written plus 13b and a minus 3. So these are two terms. And what I want to do is use these two terms in the sum that they're in as a factor in another product. So to do that, I need to wrap them in something. I need to put them inside something. So I've got a bigger box here, and I'm going to put them inside. Plus 18b minus 3, and we'll put the lid on. There we go. And I've got pots and pens. Here's my pen. I'm going to draw on some brackets. There we go. And now, even though one of them's fallen over, I can treat this as a factor within a product. So here is some other factors within a product. I've got a minus 4a. I've got my multiplication glue, and I can now stick that onto this whole sum because I've put it in brackets. So I'm now treating it as one factor within a product. So to get inside at those terms, I would have to do something to open up the box. I can't just sort of reach in and pick them out while they're a factor, while they're sort of trapped inside those brackets as a factor within a bigger product. And then this is now one big term, and inside one of the factors of this big term there are two smaller terms. So putting a sum in brackets allows us to treat it as a factor within a product, or we can divide it by something. So if I click on this term, that's the big outer term, and then inside the second, well, inside that bracket factor, I've now got a plus 13b term. Note that's got an invisible plus sign. It's the first term in its sum inside those brackets, and then a minus 3 term there. So what does it want me to select? Select the outermost term. So that's the outermost term, the outer one. There we go. And you know, this can get really, really complicated and lots of fun. So here we've got 3 terms in the main sum. Let's try and highlight those. So 1, 2, 3, and the first one would have an invisible plus sign in front of it. Those are the 3 main terms. But each of those terms has got nested terms. It's got terms inside it. Now notice here we're not using brackets. The fraction line that goes all the way under the numerator or all the way over the denominator is actually what defines, it sort of acts a bit like there being invisible brackets there when that fraction line goes all the way under. So if we tap around on here, we can see where some different terms are. That 5x is like that bit of paper I just stuck onto the box. It's a factor within a product, and its numerator, or its divisor, is a sum, which is kind of like that lunchbox with the 2 terms sort of trapped inside it. So an 8y term, a plus 8y term, and a minus z term. And then this one's got 3 terms inside its numerator factor with a 4x on the bottom, but that's kind of stuck onto that numerator as a divisor. They're stuck together into the same term. And then this one, I've got the whole term, but both the numerator and the denominator have now got sort sort of a bracket factor, if you like, with terms inside them. And again, you can't get to those terms, so I couldn't divide that 2x by that 2x because I'm not dividing a 2x by a 2x. I'm dividing a whole bracket factor by a whole bracket factor. We can't really see what's inside those boxes until we do something else algebraically to open those boxes up. And that's the subject of another topic in Algebra Tutor. So for now, we just want to recognise where those terms are, even when they're nested. So we're looking out for the plus and minus signs starting new terms, but it's going to be maybe a little bit harder to spot those invisible plus signs here. So I've actually got a couple in this term. Both those two x's have an invisible plus sign because they're the first term in their sum, but their sums are inside a bigger term in a bigger sum. Okay, so select the three terms inside the second term of the main sum. So this is the second term, and inside its numerator I've got 1, 2, 3 terms. There we go. So we can also get terms inside the exponents of factors in other terms. Usually we wouldn't consider this until we're doing some more complicated algebra, so I could actually select the 2 as that's like a first term in a sum. It's actually a plus 2, as well as the a and the b, they're inside the exponents. But yeah, usually we wouldn't consider those, if we've just got an x squared or a y squared, we're just considering the x squared or the y squared as part of the main term. Okay, so as well as brackets, we can also use a radical symbol. So that square root in this case is encasing that 18x and that plus 7x into one factor, which is then being multiplied by the 3 and the y in a product. So we've got one big outer term, and inside one of those factors we've got another sum with 2 terms. So select all the terms that are inside the square root factor, so that's that plus 18y, remember the invisible plus sign, and plus 7. Okay, and we can even get terms inside other terms inside other terms. So select the 2 innermost terms, so this is my main sum with 3 terms, and then just that second term, I've got 2 terms in the numerator. But inside the first of those 2, I've then got a factor that contains another sum with 2 terms inside it. So those are my innermost 2 terms. There we go. Okay, so let's look at some definitions then. So we've seen constant term already. Constant was a term that is just the number, just a coefficient, doesn't have any variables or doesn't have any letters in it. So select the constant term, that's the 4, that one's got an x, that one's got an x squared. So it's one without the x's in this case. Okay, so a linear term has exactly one variable, one letter, with no exponent on that variable. So it doesn't matter whether it's an x or a y or an a or a b, it's got to have just one letter there. So it can have any coefficient, it could be positive, could be negative, got a number in front of it, but it's, so minus 4x is a linear term, plus y is a linear term or a linear y term. And the name linear comes from when you have these kind of terms, they make a function defining a graph, they define straight line graphs. So you get straight lines, linear. That's where the term linear comes from. So we want to select the terms that have just got the single variable in them. I've got 2 variables being multiplied together or more than 2 variables. So that x term is linear and that y term is linear. That's got 2 variables, 2 x's being multiplied together, and that one's got 2 variables, x and y being multiplied together. That one is just a constant. So those 2. So a linear expression is an expression or a sum that is an expression, that's made up just of linear terms and possibly constant terms as well. So we can have constant terms, we must have a linear term, we're not allowed anything else for a linear expression. Okay, so the first one there, that's just an x, that's a linear term, so that's a linear expression. Second one has got a y to the power x, that's not linear at all, so not that one. Third one, minus 17, that's just a constant, so no x in there. And this one's got x squared, so that one's not linear because it's x multiplied by x. I'm looking for just the expressions where there are linear terms and maybe constant terms as well. So this minus 7x is a linear term, minus 4 is a constant term, so that's a linear expression. And this last one, that's got a y term, which is linear, it's got an x term, which is linear, and it's got a constant term, so I think that's a linear expression. There we go, it's okay with that. So a quadratic term is a term that's got exactly two variable factors. So there's two letters being multiplied together. Usually they're the same letter. So for example, 7x squared is a quadratic term in x. The variables can be different though, so you could have an xy term that's got two variables being multiplied together. But as I say, usually we'd just be looking at one type of variable, particularly as you begin learning algebra. And so you get an x squared or a y squared or an a squared term. The word quadratic comes from the Latin quadratus, which is Latin for square. So a lot of these terms are something squared, so that's why it's called a quadratic. Okay, so we've got to select the quadratic term. So it's the x squared term in this case. That's a linear term, and that's a constant term. There we go. I'm going to move that down a bit and make sure I scroll there so I can see all the possible answers. So a quadratic expression is an algebraic expression that can have quadratic terms, linear terms, or constant terms, but not anything else. It's got to have quadratic. It doesn't have to have the linear or the constant as long as it doesn't have anything else, but it can have linear or constant as well. And that sort of explains it with an example. So I'm going to go through each of these options and see whether they are quadratic expressions or not. So this one's just got a quadratic term, so that's a quadratic expression. This one's got a quadratic term plus 3x squared, that's quadratic. A linear term and a constant term, so that's okay. This one's got a linear x term, a linear y term, and then a constant term, so that's a linear expression, not a quadratic one. This has got an x to the power z, which is not quadratic, so not that one. Then this has got a quadratic in x, a constant, so they're both okay, but then the third term is a cube term, so that's actually got 3x factors being multiplied together, so that's not a quadratic. And then the last one, we've got a constant and an x squared. Okay, there we go. So a cubic term is one that has exactly 3 unknowns or 3 letter factors in the product in the term. So usually if you've just got one unknown that you're working with, like an x, then that's going to be an x cubed term. But again, it could be an x squared y term or an xy squared term or even an xyz term. But usually it's going to be something cubed, like a y cubed or an a cubed or a b cubed. So we want to select the cubic term. This one is a constant, this one's linear, this one is quadratic, this one is cubic. So that's our cubic term. Okay, and as you might be guessing already, a cubic expression then is one that must have a cubic term, and it can optionally also have quadratic, linear, or constant. So let's look at these each in turn. This one's got cubic, quadratic, linear, constant, so that one is a cubic expression. This one's got a linear and then a constant and then a cubic, so that one is a cubic expression. Some people might insist that you always write the terms within a particular order in a sum, but again, as long as you keep the plus or minus signs with the term they belong to, you can write terms in any order and it's still the equivalent sum. So this third one then, I've got a cubic term, but I've also then got something to the power 4, so that one is not cubic. That's a higher order polynomial. I'll come into that in a moment. So we'll leave that one. X cubed on its own, that's a cubic term, so that is a cubic expression. And then this one is just a quadratic, so that's not cubic. And then this one has got quadratic and cubic, so that can count as cubic. There we go. So a polynomial expression is an algebraic expression that can be written as a sum where all the terms are either constants or they have a positive integer number of variable factors with no other variables sort of anywhere else in the term. So polynomials are sums made up of constant and or linear terms, quadratic terms, cubic terms, etc. And there's some examples down here. So 5x to the power 7, that's a positive integer number of x's. There's 7 x factors in that term. Xy to the power 4, they could all be part of polynomials. But if I've got a variable in the exponent or in the denominator, then for the moment that's not going to be part of polynomials. Similarly, a square root, that's not going to have an integer exponent. So the word poly means many, and nomial in this case we can think of as being parts or terms. So it's many terms polynomial. So that's where the word comes from. So let's look at each of these ones in turn. Select the expression that is not a polynomial. The first one, that's a cubic expression, so that's okay. Second one is a polynomial. It's got an x to the power 7, but that's okay. But this third one, it's got x in the denominator, it's got a cube root, it's got x in the exponent. So that's not a polynomial. And this one is a polynomial again. That's got a quadratic term and an x to the power 5 term, so they're okay. So we've got special names for linear expressions, quadratic expressions, cubic expressions. There are some others, but as we get into the higher ones, and we tend to just have another way of referring to them. So we might refer to their order or their degree of the polynomial. So if it's a cubic expression, it's a polynomial of degree 3. If it's a quadratic, it's a polynomial of degree 2. So the order or degree of a polynomial is the number of variables multiplied together in whichever of its terms has the most of them. So it's the term with the highest power usually if you're just looking at expressions in one variable. So for example, x to the power 5 minus 3x to the power 4 plus 7x is a polynomial of degree 5 because the term with the highest power on the x is the x to the power 5. So that could be also referred to as a fifth order polynomial. Another example, we've got a sum 3 minus 4x to the power 8 plus 2x cubed. Highest power on the terms, on the unknowns there, or the term with the most variable factors in it is this minus 4x to the power 8. So this is an 8th degree polynomial. Okay, and as I said, cubic is a polynomial of degree 3, quadratic is a polynomial of degree 2, linear is degree 1, and so on. So what have we got to do here? Order these polynomials from the lowest degree to the highest degree. So I'm looking at these and thinking, which one is the lowest order polynomial? Well, I've got a linear expression here, so that's the rest have all got powers in them, so that's looking like the lowest one. That's a polynomial of degree 1. And then what have we got here? So this one, the highest power on these terms I can see is a 6. So this is going to be a polynomial of degree 6. This one here is a polynomial of degree 3. This is a cubic expression. So I think that one's going to be the next highest. And then this one, I've got constant, linear, quadratic, power 4 and power 5, so order 4 and order 5. So that one overall, the highest one is 5, so that's a 5th order polynomial. And then this one, we said earlier, was a 6th order polynomial, so that's the highest degree polynomial there. There we go. So we've got to find the polynomial of degree 7. So I'm probably looking for a power of 7 on the x. So not in that first one, that's a quadratic. That one's got a coefficient of 7, but not a degree 7 term. This one does have a power 7 on that term. It's got some lower powers, but that's okay. So that's my polynomial of degree 7. And this one's just degree 4, isn't it? Okay. Oh yeah, and remember you can always tap on Mr. Green and you can look at some of the explanations, some examples and hints in here. So you can swipe through these, remind yourself what a constant term is, what a linear term is, linear expression, polynomial expression, so on, see more examples and definitions if you need a refresher or reminder as you're going through the exercises. Let's move that down again. There we go. Okay, so select the cubic term, so I'm looking for the x to the power 3. Yeah, that's good. Right, and then a bit of nested terms with those definitions. So select the quadratic term that is inside another term. So here's a quadratic term, but it's not inside another term. Here's another quadratic term, a quadratic y squared term, but it's inside this square root factor, which is being multiplied by the 3x. So I think it's going to be that one. Okay. Okay, another ordering question. So I've got to order the polynomials from lowest degree to highest degree. So this one is a linear expression. That's degree 1. That's the lowest I can see. Then I've got a quadratic, degree 2. Then this one is degree 5. And this one is a polynomial of degree 7. There we are. Same idea again, so this one is linear, this one is quadratic, and then this one is an order 8, so 8th degree polynomial. This one is order 4, so 4 and then 8. Goes from lowest to highest. Okay, and then I've got the progress button, so I could do a few more of these to get a bit of practice if I wanted to, or I could move on to the next section if I feel like I'm ready for that, if I'm happy with these definitions. Let's do one more. So select the quadratic expressions. This one's quadratic. This one's got a quadratic term, but it's also got a higher order term, so that's not a quadratic expression. That's quadratic. Again, that's got a quadratic term, but it's got something else that's not allowed for a polynomial. That's got an x in the exponent. That one is a quadratic term on its own, so that's a quadratic expression as well. Okay, let's do one more. Select the quadratic term again, and I think it's going to be that one. That's a order 5 term, that's a linear term, and this is a constant term. There we go. Okay, so let's move on to the next section then.